color stones which you have in your stud earrings all, it is olivine. It may be olivine. Of course, there are many artificial stones now. Okay, then geotite, magnetite, limonite. So these are the you have to remember the sources of many minerals, and among that iron is very important. So keep it in mind. So I believe that you are all taking notes and marking the important questions separately. Are you doing it? I'm asking you to note certain questions are important. Kindly turn to the last page of your notebook and note all these questions. Okay. So the various forms of iron, like any other nutrient, here also you have solution iron, then adsorbed iron, then organic iron, and mineral iron. Okay. This is common for all the nutrients, isn't it? So coming to soil solution iron. What is soil solution iron? In the soil solution, iron occurs as iron hydroxide. Okay, FeOH twice. It occurs as iron hydroxide. And this is largely influenced by the redox potential. What is redox potential? Hope you have learnt about these in your 12th physics. Reduction oxidation potential, isn't it? Redox potential. So iron is greatly subjected to this redox potential. Okay, and in a well-drained soil, you will be having the ferric form of iron. And in a waterlogged soil, you'll have the ferrous form of iron. So what is the color of ferric form? What is the difference between ferric and ferrous iron? Ferric iron means what? Make it fast. We have to complete
Rust,
micronutrients
ma'am.
today.
Rust, ma'am.
Tell me.
Rust.
Very good, Monisha. Rust. Ferric form is rust. Okay, because it is oxidized. When you lay your pipes at your homes, in the beginning it would be good. Your water lines, pipes, all. And in some places, earlier they were using that kambina solvanga, isn't it? To hang your clothes, wet clothes. So at the when it is new, it would be good metallic in color. But after some time, due to oxidation, it becomes a ferric form, oxidized form, Fe3 plus. Never forget this one. Fe3 plus is the oxidized form. It is red in color. Okay, ferric. Whereas in a waterlogged soil, will you have oxygen? In a waterlogged soil, all the micropores and macropores are filled with water. You don't have air or oxygen. Then you'll have the reduction. Okay, so the ferrous form, Fe2 plus form exists. And ferrous form is in which color? I hope you remember the salt ferrous ammonium sulfate, which you would have used for organic carbon
Pale green.
estimation. Green in color, good. So the ferrous is in which color? Green in color. Okay, so again, the soil solution iron is subjected to pH, the difference in pH. So when the pH decreases by 1 unit, okay, so when the pH falls from 6 to 5 or 5 to 4 or 4 to 3, when there is 1 unit decrease in pH, then the solubility of iron increases tenfolds. Okay. Okay. So then the deficiency of iron, where do you find, in which soil pH do you find the deficiency of iron? In which soil pH you'll have more of iron? Acid soil or alkali soil or neutral soil, you'll have more of iron. Iron and aluminium are the characteristics of. Come on, make it fast. You have undergone a course on problematic soils. Acid soil contains. So long you take to answer. All right, imposition. Okay. Next class, write the imposition ferric is ferrous blood. Okay, good Satya. Mridula ferric ferrous. Okay. Okay, good. So put the answers in the chat box. Those are not able to use the mic. In acid pH or when the pH is less than 7, what are the nutrients present in the soil? Yes. Iron and aluminium. Good, Mridula. Iron and aluminium. Okay. In an acid soil, you'll have more of H plus ions, hydrogen ions, iron and aluminium. Okay. Never forget this one. Okay. So, and again in a calcareous soil means the pH ranges from 7 to 8.5, isn't it? Say in that range you have more of calcium, and iron would not be present in that soil. Okay, so this is about soil solution. Next is the chelate form. That is your organic form of iron. Okay, so the organic compounds form complex with the iron. This is known as complexation or chelation. Okay, this is known as complexation or chelation. Okay, so this acts, this is very, very important for plant nutrient uptake because these are all heavy metals, isn't it? So when the heavy metals are very easily subjected to leaching losses, even in your soil profile, you learn about the various profiles. O horizon, A horizon, B horizon, all, isn't it? So A horizon is a zone of A horizon is a zone of Priyadashini pH 8. Good, Priyadashini. For calcareous soil, you have given 7 to 8.5. Make it fast. A horizon is a zone of dash and B horizon is a zone of dash. No one's mic is working. Harini?
Ma'am.
Yes, A horizon. Amy?
Human. Ma'am. Ozone.
Yes. What is A horizon? It is a zone of Ryan.
Topsoil or surface soil, ma'am.
Okay, very good. A horizon is the top soil and B is the subsurface soil. Okay, I'm asking in terms, this one, it is known as zone of dash. Two similar terms would be there. Jyoti, Jojo. I'll see who remembers your fundamentals course. This is all these are in the initial first 2 or 3 lessons, isn't it? It starts with E and I. I give you the clue. A horizon is the zone of dash starting with E.
Alluvial.
B horizon is a very good alluviation. Alluviation. Okay. A horizon is a zone of alluviation and B horizon is a zone of illuviation. Okay. So alluviation, who has typed in the chat box? Okay. Alluviation means leaching in or washing away. So from there, most of the heavy metals would be leached at many times. Okay, whenever there is a rainfall or so, it gets leached and is transported to the lower regions. So to prevent this, and this would not be available to the crop. So to prevent this, chelation is formed by the organic matter. Thereby, the plants are able to take the micronutrients. Okay. So some examples of synthetic chelates are given here. Okay, EDTA, DTPA. So these are very common to you. You can remember the examples of 2 or 3 names you remember. Okay, EDTA is very common. You use this for calcium and magnesium estimation, isn't it? And DTPA you use for estimation of micronutrients, diethylene triamine pentaacetic acid, EDTA ethylene diamine tetraacetic acid. Okay, keep in mind triphosphoric acid, pyrophosphoric acid. So these are examples of synthetic chelates. Okay, and this is a description of the chelates. Synthetic or natural chelates, they form complex with iron. Okay, and they chelate. DTPA would chelate when the pH is less than 7, and EDTA when the pH is less than 6.5. And this one, ethylene diamine. dihydrophenyl acetic acid. So these few of these, like this one, EDDHA, okay, that is an example for fertilizer. It can be even used as a fertilizer. Okay, only then. Otherwise, if you're going to apply the micronutrients in the soil, it would get leached away. That is, one reason for you to give micronutrient spray is this one. The requirement by the crop is very low, and that if you're going to apply in the soil, it would be lost. That is why you're giving micronutrient spray also. So what are the factors affecting iron availability? The pH is a very important factor affecting iron availability, because only in low pH you have iron availability. When the pH increases, you will not have iron in the soil. There will be iron deficiency. Okay. Then carbonates and bicarbonates. So this carbonates and bicarbonates will increase complexation with iron. Iron carbonates, iron bicarbonates would be formed. This would be precipitated, and the availability to the crop is reduced. Okay, so again, in a heavy textured soil, you'll have complexation with iron, and there you'll have iron deficiency. Okay, and one important thing is that generally the flooding and submergence increases the nutrient availability of most of the nutrients. But for one thing, this would be reduced. Even under flooding and submerged condition, the nutrient availability would not be increased, but it would be reduced. We have seen this in last class or so. What is that nutrient? Put your answers in the chat box. Okay. So whereas for iron, there will be increase in the availability. Okay. And organic matter increases availability. So this all we have already learned. So interaction with other nutrients. Generally, we have two effects, antagonistic effect and progonistic effect, isn't it? Certain nutrients, when they are present in higher amount in the soil, it will reduce the availability of some other nutrients. Okay, similarly for here also, copper induced iron deficiency. Okay, this is very important. Keep it in mind. So when you have more of copper in the soil, or when you apply copper fertilizers to the soil, there will be a deficiency of iron. So this is known as copper induced iron deficiency. Okay, again manganese. When the manganese concentration increases, you also have iron deficiency. And so what is a symptom for iron deficiency? What is a symptom for iron deficiency? Make it fast.
Intervenal chlorosis, ma'am.
Good, Catherine. It is intervenal chlorosis. Iron deficiency causes intervenal chlorosis. Okay. So when nitrate is present in more amount in the soil, there will be deficiency of iron. Whereas when ammonium is present, you will not have any iron stress. Okay. The next micronutrient is manganese. So here you can find some sources of manganese, pyrolusite, manganese oxide. These all you would have learned in your inorganic chemistry 12th standard, isn't it? Pyrolusite. So pyrolusite is a source of manganese, manganite, rhodonite. Okay, the manganese concentration in the soil ranges from 20 to 3000 ppm. At an average, it is 600 ppm. So similarly, like any other nutrient, the forms of manganese in the soil are solution manganese, exchangeable manganese, organically bound manganese, and mineral manganese. This is common, isn't it? So when it is present in the solution phase, manganese is present as Mn2 plus. Okay, Mn2 plus, it is a cation. And this form is very easily mobile in the soil and gets easily leached from the soil. And if